Hey, JCMS. So we're going to keep going with our talk on our electronics. We're going to study this a little more, and hopefully we'll have a good understanding of how all our electronic devices work when we're finished with this. So in order to keep going, in order to keep learning and to go deeper, there's a few more terms that we need to understand. One of those terms is volts. I'm sure you've heard it before. Another term is amps. And then the final term that we need to know today is resistance. Okay, so I'm going to use the analogy or the picture of a water tower. Yes, that's a water tower. Running through plumbing, with water running through plumbing, to kind of demonstrate how, I always forget the L, volts, to demonstrate how volts, amps, and resistance works in a circuit. Okay, so this is our water tower. Obviously, this is the top of it, and it's filled with water. And the water tower has a certain ability to push water through the system. Okay, it can only do that so fast, depending on how good the engine is on the water tower, or however they release water. But it can only release water so quickly through the pipe. That is the equivalent in our image of volts. Okay, so we are using little 9-volt batteries, right? 9-volt batteries, 9 volts. And they can only push a certain amount of electrons through them, and that is measured in volts. So how well a battery can push electrons is measured in volts, and that's the same as a water tower pushing water through pipe. Now, when your water tower, good old JC water tower, pushes that water through those pipes, if nothing is slowing it down, that water is going to move really, really fast through there. So that's the water is going to move really fast through those pipes, and it's going to go through them and up to your homes, where you can drink it, to where you can take showers, where you can use the bathroom, you can water your lawn, you can do all these things with your water, because the tower is pushing water through. Okay. But when we do those things, when we water our lawns, oh, I'm moving the whole thing here. Give me a second. When we water our lawns like this, or when we take showers or anything like that, we're actually slowing down the water flow a little bit, right? So the water's flowing through and it comes up to your house and you're taking a shower, and that water has to go into your hot water heater and then up through the pipes into your shower, and it's got to be pushed through that. And that whole process kind of slows down, and the water's got to really push through all of these little tubes to get through. So it slows down the overall flow of the water. Same thing if you're using a sprinkler. The water comes up to the sprinkler and it slows down at the sprinkler, and it has to be forced out of there. Okay, so that slowing down when you're using components like a shower or a bathroom or a sprinkler. That's it, sprinkler. That's the equivalent of resistance. Okay, that's the equivalent of resistance. So we have our 9-volt battery, same as our water tower, and that's pushing electrons, which is water, and those electrons eventually get to a resistor. In this case, that resistor for us is a light bulb. Okay, so those electrons are flowing through from the negative end to the positive end, and they get to the filament here in the light bulb. And as they get to the filament, it looks kind of like this is a zoomed in image of the filament. The electrons get here and they all get really crowded and uptight next to each other, trying to get through this filament. When that happens, they release a lot of light and they release a lot of heat, and the light bulb lights up, and then they finally get through, and then they go on their merry way back to the other end. Okay, so this is resistance. Resistance is the only thing that's slowing down our electrons when they leave the battery and are trying to return to the other end. So the last term that we need to look at is amps. All amps is a word that we use to describe how fast electrons are flowing through an insulator. Okay, so amps in this case would be how fast this water is flowing through the pipes. So if there are no resistors, if nobody's taking a shower, nobody's watering the lawn, nobody's using any of this water, but it's still flowing through, then the water is going to be able to flow really quickly. And in this case, we would have a lot of amps. We would have high amps. Okay. If every single person is watering their lawn, and you're taking a shower upstairs, and your little brother's taking a shower downstairs, and you guys are running the sink and all these things, then we're going to have a lot of resistance, right? So that means that the amps are going to be lower in this case, or the current is going to be more slow moving through here, and it's going to go up like this and come to here and go to here, and your water pressure might be a little lower, right? Your shower won't shoot water at you quite as quickly. And it's the same thing with the battery. If we are running lots of different light bulbs and they're attached in a series like this, then we've got a lot of resistance here. So the electrons have to go through this battery, or they have to go through this light bulb and this light bulb and this light bulb, and all those resistances add up and cause a really slow movement of electrons through the wires. And so that would give it a really low amp, or there would be few amps. So maybe like 1 amp. There would be 1 amp or something like that. Something very small traveling through the wires. So now if you guys will go over to your note section in your OneNote, and you'll open that up and you'll get ready to draw with me in your OneNote. We're going to need to draw a little bit. Okay, so I want you guys to try to follow along with me. We're going to need to know how to draw circuits. Okay, so I want you guys to draw circuits. Sorry, that's a horrible C. Oh my goodness, I'll straighten that out. Okay, so you're going to need to be able to draw circuits, okay? And there are a few different symbols that represent different things. If you have something that looks like this, just like a lot of squiggly lines, zigzags, that represents a resistor, okay? And then a battery is represented like this. There's a gap in between, and there's a small line and a big line, okay? So that is a battery. Okay, so let's try to draw a circuit here. Let's try to draw a simple series circuit. So we always start with our battery. Okay, we have a battery, and let's go ahead and label it and say this is a 12-volt battery, okay? I'm just gonna write 12V. When you're drawing your wires, all you gotta do is draw a line. So draw a line, and then when we get to a light bulb, all we do is draw a resistor. So draw some lines in there like this, and then keep going and say it gets to another light bulb, draw some more lines. Keep going, get to another light bulb, draw some more lines, and all those are resistors until you make it back to your battery. It always has to make it back. So you have to make a complete circuit for the circuit to work. So hopefully I'm walking around and helping you guys as we do this, as you watch this, but now we're going to draw 2 different kinds of circuits. So I'm going to split the screen down the middle here, and we're going to have a series circuit on this side, and we are going to have a parallel circuit on this side. Oops, spelled parallel wrong there. That's why I don't teach English. Okay, so back there on the vocabulary wall, you should see 2 examples. One is a series circuit and another is a parallel circuit. So you can use those if you get stuck, but hopefully I'll be walking around and helping out too. So the difference between a parallel and a series circuit are that a parallel circuit has all of its resistors. All of its resistors can take their own path. So what I mean by that, we have our battery, and then we have some wire, and we're going through, and we come down, and we've got a light bulb here, or a resistor. And then it comes through, and it meets back with the battery. And so this resistor can take its own path straight through here. But if we make this a little more complicated, in the same circuit, if this wire keeps going, we have another resistor here. It can also take its own path, okay? And this will make it a little more clear. It can also just go ahead and meet up with this guy right here, okay? And so you do that again, and you have another parallel series in your circuit, okay? So that's they're all parallel to one another. So this is independent of this one, and this one's independent of this one, and this one's independent of this one. A series circuit means that when the electrons are flowing through our circuit, the electrons have no choice but to go through all of the resistors. Okay, so in this case, the electrons can choose, in the parallel, the electrons can choose to go through this one, or they can choose to go through this one, or they can choose to go through this one without ever touching the other resistor. But in a series, they have to touch all of the resistors. So the resistors are in a series, right? The electrons are flowing through, they're flowing through, they're flowing through. They get to this one, they have to go through. They get to this one, they have to go through. There's no option. There's no other way that they could go. They get to this one and so forth. So that's the difference between a parallel and a series circuit. Okay, so in this video, we covered what volts are, right? Volts are the ability of a battery to push electrons through a circuit. The ability of a battery, so a really high-powered battery would have a lot of volts, and it would be able to push a lot of electrons through a circuit. We talked about what amps are, and amps are just what we use to describe how well a current, so this is a wire, how quickly electrons are moving through a wire. Okay, so really high amps means that electrons are flying through the current or through the wire. Really low amps means that electrons are moving really slowly through the wire. Okay, and then we talked about resistance. Resistance is anything that slows down electrons in a wire. So if you come to a symbol like this, that means resistance, and that can be a light bulb, or that can be a computer screen, or that can be basically anything that requires energy. It can be a little piece of rubber or anything like that is a resistor, and it causes the electrons to move fast, and then they kind of slow down when they get there, okay? Well, that's not exactly accurate. It just causes the electrons to move slowly throughout the entire thing. One last thing I forgot to mention, resistance is measured in something called ohms. Ohms is a funny word. The symbol for it looks like this. So if there are lots and lots of ohms in a resistor, so this has 100 ohms, it's going to do a really good job of slowing down electrons. If it's very few ohms, so like 2 ohms, then it's not going to do too much damage in slowing down the electrons. Okay, so current measured in amps, power is measured in volts, and resistance is measured in ohms.